All right, so in this video, we're going to find terminal points within the quadrants 1 through 4 here. In the previous video, remember we found terminal points on the axes. Okay, so this is a little more complicated. On the axis, remember, on the axes, we were only dealing with values of 0, 1, and then over here like -1. With this case, we're going to be dealing with real numbers for t, and multiples of pi over 6, pi over 4, or pi over 3, okay? And if you think back to special right triangles, hopefully these numbers look familiar, okay? So we're still dealing with only 3 numbers, but they're a little more complicated this time. We've got a half, we've got radical 3 over 2, and we've got radical 2 over 2, okay? So those are the 3 values we're gonna have here for the x and y coordinates for the terminal points. The question is, which quadrant are they in? So we know whether x is positive or negative, and we know whether y is positive or negative, okay? So again, we should already know at 0, the terminal point is 1, 0. At pi over 2, the terminal point is 0, 1, okay? Pi over 6, the terminal point for pi over 6 is radical 3 over 2 for the x coordinate and 1/2 for the y coordinate. For t equals pi over 4, you should have radical 2 over 2 for both x and y, okay? And for pi over 3, we should have 1/2 for the x coordinate and radical 3 over 2 for the y coordinate, okay? So we're going to be dealing with different angles within all 4 quadrants, and we want to be able to determine what the terminal point's going to be, okay? Now, in order to do that, we're going to use what we call reference numbers, okay? And this symbol is read as T bar, okay? There's a little bar over the T there, so we call it T bar. So if our real number T, our distance we're traveling on the unit circle, is a real number, T bar is going to be the reference number that's associated with that, okay? And it's going to be the shortest distance along the unit circle between the terminal point, okay, determined by T, and the x-axis, okay? So we're going to figure out the shortest distance from wherever the terminal point may be back to the x-axis. Okay, and we're going to call that a reference number, also known as T bar. Okay, T bar is always going to be a positive value between 0 radians and pi over 2 radians. Okay, in this section we're calling them reference numbers. Eventually we're going to use what we call reference angles, which will be very similar to this. Okay, so if you learn this really well, then dealing with reference angles should be pretty easy later on. All right, so let's look at part A here. We've got our real number t here, so t is equal to negative pi over 4, okay? And what we need to do is determine a reference number, t bar, okay? That's the shortest distance back to the x-axis, okay? So let's take a look at the graph real quick. So our real number in this case was negative pi over 4. So negative means we're going clockwise, and we're going pi over 4 units, okay? So that's negative pi over 4. All right. Well, remember, our reference number is the distance from that point back to the x-axis, okay? And it's going to be positive. So t bar here is going to be pi over 4. All right, which leads me to this ordered pair, radical 2 over 2, radical 2 over 2. Now, the only thing that's going to be different here is that I'm in the 4th quadrant, okay? So that's going to tell me what the coordinates are of this terminal point here. Well, I'm using these values, radical 2 over 2 and radical 2 over 2, but what I need to determine is either or both of those going to be negative, okay? Well, this point is in quadrant 4. So quadrant 4 means the x value is positive because I'm right of the origin, and the y value is negative. So I'm going to need to add the negative there. All right, so the terminal point associated with a t equal to negative pi over 4 is going to be radical 2 over 2, negative radical 2 over 2. So again, we had our t bar as pi over 4. We were in quadrant 4. So that my x coordinate was positive, my y coordinate was negative. All right, let's take a look at the second one here, negative 7 pi over 3. Let's go to the graph. So with negative 7 pi over 3, Remember, we're negative, so we're going in this direction. Okay. Okay. So if you'll think about it, negative 6 pi over 3 would be 1 full revolution, and then I've got 1 more pi over 3. So it's going to put me at this location right here. Okay. So my reference number, again, is going to be from this point back to the x-axis. All right. So that t bar there is going to be 1 pi over 3. Okay. So what that means is I'm going to be using this ordered pair, 1/2 radical 3 over 2. Now, just like in the previous one, I had 1/2 radical 3 over 2. Okay. The only thing that's going to be different, though, because I'm in quadrant 4, my y value has to be negative. Okay. So the terminal point associated with negative 7 pi over 3 is 1/2 comma negative radical 3 over 2. All right, so negative 7 pi over 3, t bar was pi over 3. We were in quadrant 4. X value is positive, in this case 1/2. Y value is negative, in this case negative radical 3 over 2. All right. Let's go back to the graph and look at t equals negative 5 pi over 6. Okay, so negative 5 pi over 6 is going to be just shy of negative 1 pi. So it's going to get us to right there. So that's the terminal point I need the coordinates of. All right. So remember, t is going to be the closest distance to the x-axis. Okay. So t bar there is going to be pi over 6. Okay, pi over 6. So pi over 6 takes me to this ordered pair. Okay, we got to think about which quadrant I'm in. I'm in quadrant 3. Okay, so my values there, my point is going to be radical 3 over 2 and 1/2. But in quadrant 3, I should know that both those need to be negative, because in quadrant 3, both x and y are negative. Okay, so for the real number negative 5 pi over 6, it leads us to this location. T bar is pi over 6. My terminal point there is negative radical 3 over 2 and negative 1/2. And finally, we're not going to be able to determine a terminal point for this value, but I did want to show you an example where our real number wasn't in terms of something pi over 4, something pi over 3, or something pi over 6, okay? So with a real number of 2.45, all right, that's going to put us in quadrant 2, okay? Remember, pi is approximately 3.14, so 2.45 would be just shy of that. It'd be somewhere in here, all right? So remember, t bar has to be positive, so that's why I use the absolute value here. So 2.45 minus pi is about 0.69, okay? So my reference number for 2.45 is 0.69, because this is how far we are away from the x-axis, which in this case we would use pi. All right, that puts us in quadrant 2. Again, I can't give you an exact value for x and y, but I do know in quadrant 2 that x is going to be negative and y is going to be positive. All right, so that's how you use reference numbers to determine terminal points in the unit circle.